Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube. Hello, good morning to all of you. Myself, Mr. Dibyendu Mondal. Today I am discussing about initial difference in radii at the junction of a compound cylinder for shrinkage. Actually, by shrinking the outer cylinder over the inner cylinder, some compressive stresses are produced in the inner cylinder. In order to shrink the outer cylinder over the inner cylinder, the inner diameter of the outer cylinder should be slightly less than the outer diameter of the inner cylinder. Now the outer cylinder is heated and inner cylinder is inserted into it. After cooling, the outer cylinder shrinks over the inner cylinder. Thus, inner cylinder is put into compression and the outer cylinder put into tension. After shrinking, the outer radius of inner cylinder increases, whereas the inner radius of outer cylinder increases from the initial values. Let R2 be the outer radius of the outer cylinder, R1 be the inner radius of the inner cylinder. R star radius junction after shrinking, or it is common radius after shrinking. P star, that is the radial pressure at the junction after shrinking. Before shrinking, the outer radius of the inner cylinder is slightly more than R star and inner radius of the outer cylinder is slightly less than R star. Now, for the outer and inner cylinder, Lehm's equation are used. These equations are Px, that is equal to B by x square minus A. Okay, B by x square minus A, and sigma x, that is equal to B by x square plus A. The values of constant A and B will be different for each cylinder. Let the constant for inner cylinder be A2 and B2, and for outer cylinder A1 and B1. The radial pressure at the junction is same for outer cylinder and inner cylinder. At the junction, x equal to R star and Px equal to P star. Hence, the radial pressure at the junction P star equal to B1 by R star square minus A1. That is equal to B2 by R star square minus A2. So therefore, B1 minus B2 by R star square, that is equal to A1 minus A2. So B1 minus B2 equal to R star square A1 minus A2. Now, the hoop strain or circumferential strain in the cylinder at any point, that is equal to sigma x by E plus Px by Me. But circumferential strain, that is increase in circumference divided by original circumference. So 2 pi r plus dr minus 2 pi r divided by 2 pi r equal to dr by r. So that is equal to radial strain. Hence, equating the two values of circumferential strain given by equation C and D, so dr by r, that is equal to sigma x by capital E plus Px by Me. On shrinking at the junction, there is extension in the inner radius of the outer cylinder and compression in the outer radius of the inner cylinder. At the junction where x equal to r star, increase in the inner radius of the outer cylinder, that is equal to r star sigma x by E plus px by me. But for outer cylinder at the junction we have sigma x equal to b1 by r star square plus a1 and px equal to b1 by r star square minus a1, where a1 and b1 are constant for outer cylinders. Substituting the value sigma x and px in equation 2, we get increase in the inner radius of the outer cylinder r star 1 by E sigma z plus px by m, that is equal to r star 1 by E b1 by r star square plus a1 plus 1 by me b1 by r star square minus a1. Similarly, in the outer radius of the inner cylinder is obtained from equation minus r star sigma x by E plus px by me. Okay. Now, but for the inner cylinder at the function we have sigma x equal to b2 by r star square plus a2 and px equal to b2 by r star square minus a2. Substituting these values in equation 3, we get decrease in the outer radius of the inner cylinder minus r star 1 by E b2 by r star square plus a2 plus 1 by me b2 by r star square minus a2. But the original difference in the outer radius of the inner cylinder and inner radius of the outer cylinder, increase in inner radius of the outer cylinder plus decrease in outer radius of the inner cylinder. So that is equal to r star 1 by E b1 by r star square plus a1 plus 1 by me b1 by r star square minus a1 minus r star 1 by E b2 by r star square plus a2 plus 1 by me b2 by r star square minus a2. So therefore r star by capital E b1 by r star square plus a1 minus b2 by r star square plus a2 plus r star me by me b1 by r star square minus a1 minus b2 by r2 r star square minus a2. But from equation A, b1 by r star square minus a1 equal to b2 by r star square minus a2. So original difference of radii of the junction r star by E b1 by r star square plus a1 minus b2 by r star square plus a2, that is equal r star by capital E b1 minus b2 by r star square plus a1 minus a2, r star by capital E a1 minus a2 plus a1 minus a2 to r star by capital E a1 minus a2. The values a1 and a2 are obtained from the given condition. The value of a1 is for outer cylinder where a2 is for inner cylinder. A steel cylinder of 300 mm external diameter is to be shrunk to another steel cylinder of 150 mm internal diameter. After shrinking, the diameter at the junction is in radii at the junction, take E equal to 2 into 10 to the power 5 Newton per millimeter square. External dia of outer cylinder equal to 300 mm. Radius R2 is equal to 150 mm. And internal dia of the inner cylinder equal to 150 mm. and radius R1 is equal to 75 millimeter. Now the diameter at the junction equal to 250 millimeter, radius equal to R star equal to 125 millimeter. Radial pressure at the junction P star equal to 28 Newton per millimeter square. Value of capital E, that is equal to 2 into 10 to the power 5 Newton per millimeter square. Original difference of radii at junction 2 R star by capital E divided by A1 minus A2. So first find the values of A1 and A2 from the given condition. These are the constants for outer cylinder and inner cylinder respectively. They are obtained by using Lamb's equation for outer cylinder. Px equal to B1 by x square minus A1. At junction X equal to R star, that is equal to 125 millimeter, 1.25 millimeter. Px equal to P star equal to 28 Newton per millimeter square. At x equal to 150 and Px equal to 0, substituting these two conditions in the above equation, 28 equal to B1 by 125 square minus A1 equal to B1 by 15625 minus A1. So 0 equal to B1 by 150 square minus A1. So B1 by 22500 minus A1. B1 equal to 1432000 and A1 equal to 63.6. For inner cylinder, Px equal to B2 by x square minus A2. At junction x equal to R star, that is equal to 125 millimeter, and Px equal to P star, that is equal to 28 Newton per millimeter square. At x equal to 75 millimeter and Px equal to 0. So substituting these two conditions in the above equation, we get 28 equal to B2 by 125 square minus A2. So B2 by 15625 minus A2. So 0 equal to, after calculating, 0 equal to B2 by 75 square minus A2. So B2 by 5625 minus A2. Solving equation 4 and 5, we get B2 equal to minus 246100 and A2 equal to minus 43.75. Now substituting the values of A2 and A1 in equation 1, difference of radii at the junction 2 into 1 to 5 divided by 2 into 10 to the power 5, 63.6 minus of minus 43.75. So 1 to 5 by 10 to the power 5 into 107.35. Okay. Now another one problem. Actually a steel tube of 200 millimeter external diameter is to be shrunk onto another steel tube 60 millimeter internal diameter. The diameter at the junction after shrinking is 120 millimeter. Before shrinking, the difference of diameter at the junction is 0.08 millimeter. Calculate the radial pressure at the junction and hoop stresses developed in the two tubes after shrinking on. Take capital E equal to 2 into 10 to the power 5 Newton per millimeter square. External diameter of the outer tube, that is equal to 200 millimeter. Radius equal to 100 millimeter. Internal dia of the outer tube, that is equal to 60 millimeter. Radius equal to 30 millimeter. The diameter at the junction after shrinking, that is equal to 120 millimeter. Radius equal to 60 millimeter. Before shrinking on the difference of before shrinking, the difference of dia at the junction equal to 0.08 millimeter. Difference of original radii 0.04 millimeter. Value of capital E, that is equal to 2 into 10 to the power 5 Newton per millimeter square. So let P star, that is equal to radial pressure at the junction. So original difference of the radii at junction, that is equal to 2 R star by capital E, A1 minus A2. So that is equal to 0.04 equal to 2 into 60 divided by 2 into 10 to the power 5 A1 minus A2. So 0.04 into 2 into 10 to the power 5 divided by 2 into 60 A1 minus A2. So A1 minus A2, that is equal to 200 by 3. Now using the Lamb's equation for outer tube, Px equal to B1 by x square minus A1. Sigma x, that is equal to B1 by x square plus A1. At x equal to 100 millimeter, Px equal to 0. Substituting these values in equation 2, 0 equal to B1 by 100 square minus A1. So B1 by 10000 minus A1. At x equal to 60 millimeter, Px equal to P star. Substituting these values in equation 2, P star equal to B1 by 60 square minus A1. So that is equal to B1 by 3600 minus A1. Now applying Lamb's equation for inner tube, Px equal to B2 square B2 by x square minus A2. And sigma x B2 by x square plus A2. So at x equal to 30 millimeter, Px equal to 0. Substituting these values in equation 6, 0 equal to B2 by 30 square minus A2. So that is equal to B2 by 900 minus A2. At x equal to 60 millimeter, Px equal to P star. Substituting these values, P star equal to B2 by 60 square minus A2. So B2 by 3600 minus A2. B2 by 3600 minus A2, that is equal to B1 by 3600 minus A1. So B2 minus B1 by 3600 equal to A2 minus A1. But from equation B1 equal to 10000 A1. B2 is equal to 900 A2. Substituting these values in equation X, we get 900 A2 minus 10000 A1 by 3600 equal to A2 by A1. So 900 A2 minus 10000 A1, 3600 A2 minus 3600 A1. Now from this equation, A1 is equal to 2700 minus 6400 A2. So after simplification we get minus 27 by 64 A2. Substituting the value of A1 in equation, minus 27 by 64 A2 minus A2 equal to 200 by 3. So minus 27 A2 plus 64 A2 by 64 equal to 200 by 3. So A2 is equal to minus 46.88. A1, that is equal to 27 by 64 into 46.88, 19.77. B1 is equal to 10000 into A1. So that is equal to 197700. B2 is equal to 900 into A2. So minus 900 into 46.88. So 421.92. Another one is the radial pressure at the junction. Radial pressure at the junction P star B2 by 3600 minus A2. So that is equal to 35.16 and P star is equal to 35.146. Hoop stresses in the two tubes after shrinking on the hoop stresses can be calculated from equation this. Sigma x equal to 197700 by x square plus 19.77. So here sigma 60 equal to 74.68, sigma x equal to this, and sigma 30 minus 93.76 Newton per millimeter square. Compressive, this is the compressive stress. Okay, thank you. Last, if you like my video, you have to subscribe. Okay, thank you.